Hello, IM3 students. Good morning, everyone. Today we're going to be beginning Module 11, and that is a whole module that deals with the radical and rational exponents. So radical expressions are basically anything that have roots, and then the rational exponents is rewriting those as a base. A base with a fraction power. So that's what Module 11 deals with. And hopefully you've had a chance to go and watch the link on the real world video. So if you haven't done so, go ahead and watch the video first. And now we are ready to begin. So you will be today, you will be able to define rational exponents in terms of roots. So we're going to be dealing with the roots first. And let's take a look at what the root means. So if we have an expression that has a base as an x, this is the radical form. When you see this symbol right here, it actually is a radical form, so it's a radical function. And then this number here is the index. That tells you basically how many of these factors do you need in order to simplify the expression. And if you have a number here in the exponent position, that will be just the exponent. And then if we want to rewrite this in the rational expression form with the rational exponent, which means fraction. So I usually tell the students what's on top stays on top. So if we have the exponent here that is on top, it's going to remain on top for the rational exponent. And then what's outside is going to go on the bottom. So that's how I kind of ask you guys to remember. So hopefully that helps throughout the module. And here is a quick review on square roots. So basically square roots is kind of like you have half of a factor, you need the other one, you need another one of the exact same thing. So you guys mostly should have taken roots of like square root of 4, which is 2, because basically the square root of 4 is like square root of 2 to the second power. So since you have 2 and the radical cancels each other, and that's how you get the answer is 2. You're also going to be working with cube roots where you're going to need 3 of them. So for example, if you want to take the radical of 8, we can actually, the cube root of 8, that means we can rewrite it as 2 times 2 times 2, which means 2 to the third. And now the cube and the cube root cancels out, and you'll have 2 as an answer. That's kind of like how roots work. And in an essence, the nth root is going to be, you're going to need n of them in order for you to simplify. So here's a note. When a number has more than one real root, the magical sign indicates only the principal or positive root. So we're going to just basically take the positive signs for the roots when we are taking roots, especially like even numbers, like square root or fourth root. A rational exponent is when an exponent that can be expressed in a fraction form, such as m over n, where m is an integer and n is a natural number. So these are both whole numbers, okay? And in the first example here, how can you express a square root using an exponent? Well, if we think of the number, what is, if we rewrite the square root of a as a to the m power, what is m equal to? So if you can think of like the exponent is 1, and then the square root outside is actually 2, because you're taking like a fraction, 2 right here, then m should equal to 1/2, because you are now rewriting this as a to the 1/2 power. So that's why m should equal to 1/2, and that's what basically that means. Another way to actually solve for this is that if you have the square root of a and you want to set it equal to m, so this is like another way to solve it. We can rewrite, we can square both sides to get rid of the radical. So we got a equals a to the 2m. And now we realize that there's a 1 here because, you know, anything to the 1 power is itself, right? So the base are actually equal, right? A equals A. So therefore, the exponents should equal to each other. So we got 2m equals 1. And finally, dividing by 2, you'll have m equals 1/2. So you have another way of solving for m, which is 1/2. So hopefully that helps. And now you're going to try to find the answer for this one, which asks you to express a cube root using an exponent. So if you want to try it first, pause the video. Otherwise, you can just keep watching to see how it is done. So in the same essence that we just did the square root, we're going to do the same thing for the cube root. So we can start by taking the cube root of a and cube both sides to undo the cube root. So we'll have a equals a to the 3m. And again, this is a 1 here. And so therefore, because the base are equal, we have the power is equal to each other. So 3m equals 1, and then dividing by 3, we will have m equals 1/3. In this case, for cube root, m is 1/3, which means the exponent or the power is 1/3, whereas the square root is a 1/2. In the discussion problem here, it says, examine the reasoning in step A and B. Can you apply the same reasoning for any nth root where n is a natural number? And explain. So if you have an nth root of a, and you can set that equal to a to the m, you can do it as pretty much the same. You can raise it to the nth power and then solve. So that's why you're going to end up with a equals a to the mn, and then because mn equals 1, so we can solve for, because base are equal, we can solve for n again, or m, you can solve for m, and so m is equal to 1/n. So that's actually 1/nth power. So it does work for any root. And here's a couple of practice problems. Let's practice rewriting these radicals in rational exponents, which means translating from the square root or just any roots to a power with a fraction. So this is a square root, and we already know that square root is a 1/2 power. And this is a square root again, but we have 21 to the 3, the power. Remember, what's on top stays on top, so it's 3/2. Again, that number invisible is 2 outside. And this one is going to be 6 to the what's on top stays on top, 4/3. And then this is 40 to the 2/3, 15 to the 2/5, and then 25 to the 1/6. And that's how you can rewrite the radical forms to exponent forms, which means fraction exponents. And now we're going to go backwards. We're going to go from fraction form back to the radical form. So we realize that the base is 2 tells me that this is going to be a square root. And we have x to the 3rd power. Remember, what's on top stays on top, right? And fourth, on the bottom, it's going to be a 4th root, and then 3 to the 5th. And this is a cube root of 5. And this is a 5th root of 10x to the 2nd power. And this is a square root of 3x to the 5th power. And this is cube root of 8 to the 4th power. And so that is how you can convert backwards from exponent form to the radical form. And that's a wrap for today's lesson. You may go ahead and log into Google Classroom and see what is your homework for today. Have a good day.